Imagine yourself standing in the cool dairy aisle of a grocery store, where the shelves are packed with carton after carton of eggs. On one side, you see clean, bright white eggs, almost too perfect in appearance. On the other side, tucked into rougher-looking cardboard cartons, sit the brown eggs, warm in color, rustic in feeling, and often a little more expensive. At that moment, something very familiar happens in the mind of many shoppers. Without even thinking too deeply, we begin to feel that the brown egg must be the better one. It looks more natural. It feels as if it came from a quiet family farm, gathered from a nest by hand in the morning sun. Meanwhile, the white egg can seem plain, industrial, and less special, even though it may have come from a healthy, well-managed flock just the same. So we pay a little extra, place the brown eggs in our cart, and walk away feeling that we have chosen something healthier, cleaner, and more wholesome for the people we care about. But after many years around chickens, barns, feed sacks, nesting boxes, and farm families, I can tell you this. That belief is one of the most common misunderstandings in the egg aisle. The real difference between brown eggs and white eggs is not about nutrition. It is not about richer flavor. It is not even about a stronger or better shell. To understand the truth, we have to step away from the supermarket shelf and look directly into the chicken coop. We need to look at the hen, her breed, her genetics, her feed, and the basic economics behind raising different types of laying birds. In this journey, we are going to crack open the simple science behind egg color, uncover why some eggs cost more than others, and see why a shell that looks more farm-fresh is not always a sign of greater value inside. So settle in, picture the quiet sounds of a working farmyard, and let's begin with the hidden story behind one of the most ordinary foods on the table, the humble egg. Part 1. The earlobe code in chicken genetics. To understand where egg color truly comes from, we need to stop looking only at the egg carton and start looking at the hen that laid the egg. After many years around poultry houses, backyard coops, and farm flocks, one thing becomes very clear. The color of an eggshell is controlled mainly by the breed and genetic makeup of the hen. In poultry keeping, there is a simple and surprisingly useful rule that many experienced farmers know. If you want to guess what color egg a hen may lay, take a look at her earlobes. Yes, chickens do have earlobes. They are the small patches of skin just below the ear on the side of the head. As a general rule, hens with white feathers and white earlobes usually lay white-shelled eggs. The best-known example is the white leghorn, a light, active, highly efficient laying bird that has become one of the most important breeds in white egg production around the world. On the other side, hens with reddish-brown feathers and red earlobes usually lay brown-shelled eggs. Breeds such as the Rhode Island Red and Plymouth Rock are classic examples. These are sturdy, dependable birds, often loved by small farms and backyard keepers, and they are the source of many of those brown eggs people see in stores. But chicken genetics does not stop with white and brown. Some special heritage breeds, such as the South American Araucana and the Americana, carry unique genetic traits that allow them to produce blue or green eggs. Scientists have linked this to a genetic element known as EAVHP, which helps trigger the deposit of colored pigments in the shell. That is why some hens lay eggs that look almost like they came from an Easter basket. Still, whether the egg is white, brown, blue, or green, the color is not a sign that one egg is automatically healthier or better than another. It is simply the genetic signature of the bird that laid it. But that leads to the next important question. How does that color actually get onto the shell? And why does a brown egg hide a small surprise when you crack it open? To answer that, we need to look inside the hen's biological egg-making system. Part 2. The final hour masterpiece. How the oviduct paints an egg inside the body of a laying hen. An incredible process happens almost every day. From start to finish, it usually takes about 24 to 25 hours to form one complete egg. This process moves through different sections of the hen's oviduct, almost like a carefully organized farm production line. It begins in the ovary, where the yolk develops and is released. Then the yolk travels into the magnum, where layers of thick, protein-rich albumin, or egg white, are added around it. After that, it moves into the isthmus, where the inner and outer shell membranes are formed. Finally, the egg reaches the uterus, also called the shell gland. This is where the egg spends most of its time, roughly 20 hours. During this long stage, The hen's body deposits calcium carbonate crystals, mainly calcite, over the shell membrane to build a hard, protective outer shell. Pure calcite is naturally colorless, which means every egg begins with a white shell base. Whether the hen is a white leghorn or a Rhode Island red, the basic structure of the shell starts the same way. For hens that lay brown eggs, the color is added near the end of this process. In the final hours, cells lining the shell gland begin producing a natural pigment called protoporphyrin IgG. This pigment is connected to the breakdown of heme, a component related to red blood cells. During the last 3 to 4 hours, this pigment mixes with a protein-rich coating known as the cuticle, or bloom. About 90 minutes before the egg is laid, that pigment-rich coating is placed on the outside of the shell. In simple farm language, the brown color is almost like a final coat of paint brushed onto the egg before it leaves the hen. That is why, when you crack open a brown egg and look closely at the inside of the shell, you will usually see that the inside is still white. The brown color sits mainly on the outside. In fact, with enough rubbing, scratching, or soaking in mild vinegar, that outer pigment can be reduced or removed, revealing the white calcite shell underneath. Blue and green eggs are a little different. Their color comes from a pigment called biliverdin, which is added earlier in the shell gland. Because of that, the color can go deeper through the shell instead of sitting mostly on the surface. It is amazing to think that a hen's body follows such a precise and complex process just to color a shell that most people will eventually throw away. But in farming, these small details matter because they remind us how much biology is hidden inside even the most ordinary egg. Part 3. The myth of the sunset yolk. Most people have had this experience at least once. You crack open a farm-fresh egg and see a deep orange yolk, rich and glowing like a small sunset in the pan. Then you compare it with the pale yellow yolk of a regular supermarket egg and immediately assume the darker yolk must taste better and contain far more nutrition. This is one of the most common beliefs among egg buyers, but the truth is more specific than many people realize. The color of the eggshell has no control over the color of the yolk. A brown egg does not automatically have a darker yolk, and a white egg does not automatically have a pale one. Yolk color comes from one main factor, the hen's diet. When a hen has access to pasture and can forage naturally, she eats a wider variety of foods. She may pick at fresh grasses, seeds, insects, grubs, and worms. Many of these natural foods contain carotenoids, which are organic pigments and antioxidants, including lutein and zeaxanthin. Once the hen digests them, those pigments are deposited into the yolk, giving it a deeper yellow or orange color. Hens raised in conventional indoor systems, eating a more standardized ration based on ingredients like yellow corn, soy, or alfalfa, often produce lighter yellow yolks. Commercial egg producers understand very well that people like the look of darker yolks. In some markets, especially places like Europe and Australia, darker yolks are strongly preferred. To meet that demand, producers may add natural carotenoid sources, such as marigold petals or red bell pepper, also called capsicum, or approved synthetic equivalents into the feed. In practice, they can adjust yolk color on a scale to match what customers expect to see. This is where human psychology plays a powerful role. In blind taste tests, when people cannot see the yolk color, or when the color is masked, they often cannot reliably tell the difference between a dark orange yolk and a pale yellow yolk by taste or smell alone. In other words, we often eat with our eyes before we eat with our mouths. A rich orange yolk makes us feel that the egg is more natural, more nutritious, and more farm-fresh. And while a darker yolk can suggest higher levels of certain antioxidants, like lutein and zeaxanthin, the basic protein, calorie content, and main macronutrients of the egg remain very similar. So if the inside of the egg is not automatically better just because the shell is brown or the yolk is darker, we arrive at the question many shoppers ask: why do brown eggs usually cost more? Is it just clever marketing, or is there a real farm reason behind the price? Part 4. The price of an appetite. Why brown costs more. To understand why brown eggs often cost more than white eggs, we need to look at two very practical things every farmer understands well: animal biology and farm economics. This is not some hidden conspiracy, and it is not simply a clever trick to make shoppers spend more money. In most cases, the price difference begins with one simple fact: The hen that lays the brown egg usually eats more. Brown eggs are commonly produced by larger, heavier breeds, such as the Rhode Island Red or Plymouth Rock. These birds are strong, useful, and well-loved on many farms, but they are not as lightweight or feed-efficient as the classic white leghorn. A mature white leghorn is a smaller, lighter bird, usually weighing around 2.0 to 2.5 kilograms. Because her body is compact, she does not need as much feed just to maintain body heat, movement, and basic daily functions. She is also an extremely efficient layer, often requiring only about 1 pound of feed to produce a dozen eggs. A Rhode Island Red, on the other hand, is a bigger dual-purpose bird, commonly weighing around 3.0 to 3.5 kilograms. With that larger body comes a larger appetite. She needs more feed and water every day simply to support her size, her body temperature, and her normal metabolism. In some comparisons, she may require around 3.5 pounds of feed to produce a dozen eggs. Then we have egg production itself. Modern leghorn hybrids are remarkable layers, often producing around 300 to 320 white eggs in a year. Many brown egg breeds still lay well, but they often produce fewer eggs overall, usually somewhere around 200 to 300 eggs annually. For a farmer, this matters a lot, because feed is one of the biggest ongoing costs in egg production. If a hen eats more, lays fewer eggs, and needs more resources to maintain her body, the cost of producing each egg goes up. Those extra bags of feed, day after day, must be covered somewhere, and eventually that cost appears in the price you see at the store. So when you buy brown eggs, you are not necessarily paying for a more nutritious or higher quality egg. In many cases, you are simply helping cover the cost of raising a bigger, hungrier chicken. And in today's changing agricultural world, that difference in appetite is beginning to affect more than just price. It is also becoming part of a much bigger environmental conversation. Part 5. The Carbon Equation. Why supermarkets are going white. Today, agriculture is under more pressure than ever. Farmers, food companies, and supermarkets are all facing the same difficult question. How do we produce enough food for a growing population while reducing waste, feed use, land pressure, and environmental impact? That is why the difference between white-feathered and brown-feathered laying hens has become more important than many shoppers realize. What once looked like a simple choice between two shell colors is now connected to efficiency, sustainability, and carbon footprint. In the United Kingdom, this issue became very clear when Sainsbury's, one of the country's largest supermarket chains, announced a major shift in its own brand egg range. The company began phasing out brown eggs and replacing them with white eggs. At first, that might sound surprising. Many shoppers have always associated brown eggs with a more traditional, rustic, farm-style image. So why would a large supermarket risk changing something customers were already used to? The answer came from a life cycle carbon assessment carried out by SAC Consulting. According to that assessment, white eggs had a 12.7% smaller carbon footprint per kilogram than brown eggs. That difference comes from several practical advantages found in modern white-feathered leghorn-type laying lines. First, white hens generally need less feed to produce the same amount of egg mass. Less feed means less land, water, fertilizer, and fuel are needed to grow, transport, and process the crops used in poultry feed. Second, modern white hybrids can often stay productive for a longer period, sometimes up to around 100 weeks of age. Many brown layers are productive for a shorter period, often closer to 86 to 90 weeks. When a hen stays productive longer, the cost and carbon impact of raising that young pullet are spread across more eggs. Third, white-feathered laying lines are often valued for calmer flock behavior in large systems. Better flock behavior can mean fewer problems such as feather pecking, improved welfare, and better overall survival rates. Fourth, white eggs can be easier to grade in large packing facilities. Automated grading systems use high-speed light scanners to check for internal defects or blood spots. Darker brown shells can make that process more difficult because the pigment reduces how easily light passes through the shell. White shells are easier for these systems to scan accurately, which can reduce grading errors and waste. This teaches us something very important about farming. Sustainability does not always come from a new machine or a complicated invention. Sometimes it comes from understanding the natural efficiency already present in the animals we raise, then making practical choices based on biology, feed use, and long-term farm performance. Part 6. The Fishy Egg Mystery, a genetic plot twist. Now let's look at one of the stranger and more surprising issues in poultry keeping, the mystery of the fishy-tasting egg. This is one of those problems that can confuse both backyard chicken keepers and commercial egg producers, because the egg may look perfectly fresh from the outside. Maybe you, or someone you know, has cracked open a fresh egg, cooked it, and suddenly noticed a strong, unpleasant smell or taste like rotting fish. At first, it is natural to wonder if the egg has gone bad, or if the hen somehow ate something strange. But in some cases, the cause is not spoilage at all. It is genetics. This condition is linked to a genetic issue that is often compared to a rare human condition called trimethylaminuria, also known as fish odor syndrome. Here is what happens. When chickens digest certain feed ingredients, such as canola meal, also called rapeseed meal, soy meal, or wheat, bacteria in the lower digestive tract can ferment compounds from that feed. During that process, they produce a strong-smelling compound called trimethylamine, or TMA. In genetically normal chickens, including almost all white egg-laying leghorns, this TMA is absorbed into the bloodstream and carried to the liver. There, an enzyme called flavin-containing monooxygenase 3, or FMO3, changes the smelly TMA into an odorless compound called TMAO. After that, the bird can safely excrete it. But some brown egg-laying breeds can carry a hereditary autosomal recessive mutation in the FMO3 gene. If a hen inherits 2 copies of that mutated gene, her liver cannot produce a properly functioning FMO3 enzyme. When that hen eats a diet high in canola or rapeseed meal, the fishy TMA is not broken down the way it should be. Instead, it builds up in her bloodstream and can move into the fat-rich yolk while the egg is developing. The result is a fresh, attractive-looking brown egg that can smell and taste strongly of fish. To prevent this problem, feed manufacturers often limit canola meal in diets made for brown-laying hens. At the same time, breeding companies use genetic screening to identify and remove this mutation from commercial brown layer lines. This unusual genetic detail is a strong reminder of how closely animal genetics, feed choices, and food quality are connected. What happens inside the hen's body can show up directly on the breakfast plate, even when the egg looks perfect from the outside. Part 7. The True Anatomy of Egg Quality. If shell color does not decide egg quality, then what really does? When you crack an egg into a pan at home, how can you tell whether that egg is truly fresh and high quality, or already starting to decline? In the egg industry, professionals do not judge internal quality by looking at whether the shell is white, brown, blue, or green. They look at what is happening inside the egg. One of the main scientific measurements used for this is called the Haw unit. The Haw unit, named after Raymond Haw, measures the height of the thick albumin, or egg white, in relation to the total weight of the egg. In simple farm language, it tells us how firm, fresh, and well-structured the egg white is. When you crack a fresh, good-quality egg onto a flat pan, you will usually see 2 parts of the white. One part is the thick white, which stands higher and hugs the yolk closely like a firm cushion. The other part is the loose white, which spreads out more thinly around it. A high Haw unit score means that thick white is strong and firm. In grading terms, a score above 72 is considered grade AA. That thick albumin matters more than many people realize. It helps hold the yolk in the center, keeps the yolk from breaking easily, and gives you those neat, beautiful poached eggs, instead of an egg white that spreads into a cloudy mess in the water. As an egg gets older, the internal structure gradually weakens. Carbon dioxide slowly escapes through thousands of tiny pores in the shell. As that happens, the pH of the albumin rises, and the thick white begins to thin out. That is why an older egg often spreads wide and watery across the pan, while a fresh egg stays tighter and taller. So what affects this real, physical quality? First is the age of the hen. Younger hens usually lay smaller eggs with very thick whites and strong shells. As a hen gets older, her eggs often become larger, but her ability to produce enough calcium and firm albumin does not always increase at the same pace. That can lead to thinner whites, weaker shells, and eggs that crack more easily. Second is flock stress. This is a major factor in poultry care. When hens are stressed by predators, overcrowding, sudden loud noises, heat pressure, or poor handling, Their bodies release stress hormones such as epinephrine, also known as adrenaline. This can interfere with the delicate process of shell and cuticle formation inside the uterus. The result may be pale, chalky, misshapen, or structurally weak eggs. Then there is the remarkable role of medullary bone. To form just one eggshell, a hen must move a large amount of calcium through her body. She does this using a special type of bone tissue called medullary bone, which works like a fast-release calcium reserve. This is a biological feature found in egg-laying birds, crocodilians, and even ancient dinosaurs. If a laying hen does not get enough calcium in her diet, her body will draw calcium from her own bones to build the shell. So true egg quality is not written on the outside of the shell. It is shaped by freshness, hen age, flock stress, nutrition, calcium supply, and the way the birds are managed every single day. Part 8. Decoding the cartons and your daily farm lesson. Now that we understand egg color, genetics, shell formation, yolk color, feed efficiency, and real egg quality, we can use that knowledge the next time we stand in front of an egg display at the store. If you want to choose better eggs for your family, do not let shell color be the deciding factor. A brown shell does not automatically mean a healthier egg, and a white shell does not mean a lower quality egg. The real information is usually found on the carton label, because that tells you more about how the hens were raised and what kind of production system they came from. Cage-free means the hens are not kept in small individual battery cages. They can move around inside a barn, stretch, perch, and lay eggs in nest areas. But cage-free does not always mean outdoor access. In many systems, the birds still live indoors, sometimes in crowded conditions, without pasture or direct sunlight. Free-range means the hens live in barns but are given daytime access to the outdoors. This can improve their quality of life, especially when the outdoor area is useful and well managed. Access to natural light and outdoor space may also help increase vitamin D levels in the eggs, depending on how much time the hens actually spend outside. Pasture-raised is often considered the highest standard by people who care about natural behavior and diverse feeding. These hens spend much of their time on open grassy areas, where they can forage for grass, seeds, insects, grubs, and worms. Because their diet is more varied, pasture-raised eggs can contain higher levels of certain nutrients, including up to double the vitamin E, 38% more vitamin A, and more omega-3 fatty acids compared with conventional eggs. Omega-3 enriched eggs come from hens whose feed has been supplemented with ingredients such as flaxseed, fish oil, or marine algae. These eggs are designed to contain much higher levels of heart-supporting omega-3 fatty acids, sometimes up to 8 to 10 times more than standard eggs. Once you bring eggs home, there are a few simple ways to check freshness. The float test is one of the easiest. Place the egg gently in a bowl of water. A very fresh egg will sink and lie flat on its side. As the egg ages, the air cell inside grows larger. If the egg stands upright on the bottom, it is older but may still be usable. If it floats to the surface, it is best to discard it. The shake test is another old farm-style check. Hold the egg close to your ear and shake it gently. If you hear a sloshing sound, the internal membranes and whites have weakened, which means the egg is old. A fresh egg should feel quiet and solid inside. You can also check the Julian date on the carton. This is a 3-digit number that tells you the day of the year the eggs were packed. The number 001 means January 1st, and 365 means December 31st. The closer that number is to the day you are buying or using the eggs, the fresher they are likely to be. That is the practical lesson. Do not shop by shell color alone. Look at how the hens were raised, how fresh the eggs are, and what kind of nutrition or production system the carton actually represents. Conclusion: Soul of the farmyard. As we close the gate on this lesson, the truth becomes simple and very clear. For many years, people have paid more for brown eggs because they looked more rustic, more natural, and more wholesome. A brown shell made many shoppers feel they were buying something closer to the farm, something healthier for the family, something better than the plain white eggs sitting beside it. But nature has a quiet way of correcting our assumptions. Under that brown layer of pigment is the same basic white shell structure, protecting the same kind of nutritious egg found inside a white shell. The color is not a measure of quality. It is a genetic coat of paint, a breed signature left by the hen, not proof that one egg is automatically better than another. And that gives us a lesson far beyond the egg basket. In modern life, we often spend too much time judging the outside of things. The package, the color, the image, the label, the polished appearance. We are easily led to believe that if something looks more expensive, more rustic, or more attractive, then it must contain greater value. But anyone who has spent real time around animals and farm life knows that the truth is often deeper than the surface. The plainest hen in the yard may be the most dependable layer. The simplest looking egg may be just as nourishing as the one with the richer colored shell. Real value is built from the inside out. That is true for eggs, and it is true for the way we care for our animals. Quality comes from good feed, clean water, proper housing, low stress, healthy genetics, and a living environment that allows an animal to thrive. It is not created by shell color, feather color, or the first impression we see from the outside. So the next time you stand in the grocery aisle or gather eggs from your own backyard coop, look at those eggs with a little more understanding. Remember the quiet 24 to 25-hour miracle inside the hen that created each one. Remember that every shell, whether white, brown, blue, or green, carries a story of genetics, nutrition, care, and management. Did you always believe brown eggs were healthier? And if you keep hens at home, what colors show up in your egg basket? Thank you for spending this time with Farmyard Care. If this journey through the science and wisdom of the chicken coop was useful to you, give this video a thumbs up, share it with someone who loves farm life, and subscribe so you never miss the next barnyard lesson. Until next time, keep caring for your land, keep caring for your animals, and most importantly, keep looking past the surface to find the true goodness inside.